All right, here we go, working our last example. So the first thing we need to do is we need to figure out what the formula is for aluminum chloride because we're going to have to use its molar mass as a conversion factor. So look at your periodic table. I want you to pause the video. I want you to figure out the formula for aluminum chloride and its molar mass from the periodic table, so we have those two things to refer back to. Okay, so let's see if we figured it out. So when you have aluminum chloride, the charge for an aluminum ion is +3. The charge for a chloride ion is -1. So when you write the formula, it's going to be AlCl3. And then when you add up the molar mass, you should get 133.341 grams per mole. Okay, we're going to need those two things in order to work this problem. All right, so let's look at our first question. It says, how many aluminum ions are present? So again, we always start with what we know, which is the mass of aluminum chloride. So we're going to start with 35.6 grams of aluminum chloride. Okay. So we want to get from aluminum chloride, we have mass of aluminum chloride, so what can we figure out? Well, looking at your flow chart that's directly above this problem, we can get from mass to moles, right? So that's where our molar mass comes into play. So we know that 1 mole of aluminum chloride has a mass of 133.341 grams. Okay, so we canceled our grams. Now, from moles of aluminum chloride, we want to figure out how many aluminum ions we have. So this is where we use that mole ratio. All right, so in 1 mole of aluminum chloride, how many moles of aluminum ions are there? Well, what's the subscript of aluminum? It's a 1, so there is 1 mole of aluminum ions in 1 mole of aluminum chloride, okay? Now, the question says how many ions, not how many moles of ions, but how many ions. And so this is where we can add one more step in and figure out, to get from the number of moles to the number of actual particles, what do we use? We use Avogadro's number. So there are 6.02 times 10 to the 23rd aluminum ions in 1 mole. So our moles cancel here. Our moles cancel here. So now we know how many aluminum ions are present in that mass of aluminum chloride. So we want to do the math, round to the 3 sig figs that we have to begin with, and that should give us 1.61 times 10 to the 23rd aluminum ions. There we go. Okay, so we just answered A. Now we're going to take a look at... Okay, so for question B, the question is how many chloride ions are present. So we're going to start the problem the same way, but the difference is going to be how we end. So we're still going to start with what we're given, 35.6 grams of aluminum chloride over 1. We're still going to convert it to moles, just like we did before, because we can't do anything from grams. We have to be in moles. That's what's central. We use our molar mass, which we said was 133.341 grams. And this is of AlCl3. Okay, so we've canceled our grams. Now, we're trying to find chloride ions. So this time, we know our formula is this, right? How many moles of chloride ions are there in 1 mole of aluminum chloride? Well, our subscript tells us there are 3 moles of chloride ions in every 1 mole of AlCl3. So we have a different mole ratio than we did with the aluminum ions because we have different subscripts for our 2 ions. And then again, we want to get to how many actual ions are present, not moles, so we use Avogadro's number. All right, again, 3 sig figs, we do our calculation, and we get 4.82 times 10 to the 23rd chloride ions. Very good. That's our final answer for question B. All right, now we want to answer question C. And question C says, what is the mass in grams of 1 formula unit of aluminum chloride? So we haven't really used that term formula unit a lot. It's kind of the same idea as a molecule. It's just that formula unit is used for ionic compounds, where molecule is used for covalent compounds. So because we're dealing with aluminum chloride, which is ionic, we use the term formula unit. And it basically means 1 aluminum and 3 chloride ions. That's a formula unit, okay? So we want to figure out the mass in grams of one of those. So we're going to start with 1 formula unit of AlCl3. Okay, now we're basically over on the particle side of our flow chart. So from the particles, we can get to the moles, and from the moles, we can get to the grams, and that's what we're trying to find. We're trying to find the mass of 1 formula unit. Okay, so to get from formula units to moles, what do we want to use? We want to use Avogadro's number. So 1 mole of AlCl3, there are 6.02 times 10 to the 23rd formula units of our compound. So the formula units cancel. All right, now we're in moles. We want to get to grams, so we're going to use our molar mass again. 133.341 grams per mole of aluminum chloride formula units. So our moles cancel. Okay. Now, I would hope that you expect this number to be very, very small. We're talking about the mass of 1 AlCl3. That's it. 1 aluminum ion, 3 chloride ions, all bonded together. That's what we're going to get the mass of. And it should be a very small number because we're dividing by Avogadro's number. So when we look at our answer, we want 2.21 times 10 to the negative 22 grams. That's going to be your final answer. That is the mass of 1 formula unit of aluminum chloride.